Assalamu alaikum, Bismillahirrahmanirrahim. We're discussing about Arabic groups in JNCIS-SP service provider uh, track. Arabic groups, why we use Arabic groups? Basically, we use Arabic groups to share the routing or route in different routing instances or different PRF. So it can be used, Arabic groups can be used when you use a VPN like a routing instance, and you can also deploy in multi-host networks, and you can also deploy in filter-based forwarding. And after one section, you have filter-based forwarding, and you will get details in RIB groups, how to deploy RIB groups for filter-based forwarding. Okay. So our main purpose is to share the route from one routing instance to another routing instance. This is the main reason to use RIP. So this is the just conceptual graph. This route can be shared with table one and table two. Table one means you can consider one routing instance is table one, another routing instance is table two. If you want to share route between table one and table two, it can be from another table, or it can be from table one to table two, or vice versa, table two to table one. When you share routes between routing instances, there is three options to share the routes. Number one is instance import, and number two is instance export and auto export. Okay, so the definition of import RIP, definition of export RIP, and import policy. The import RIP means indicate tables in which route should be placed. That means you want to take route from another table. If you just mention import RIP and the routing table name. First name is source routing table, and next name will be the destination route table. So in that case, if you if you want to copy VPN A or customer A route to common VRF or common routing instances, or customer A to customer B routing instances. Okay. Okay. Similarly, export means if you want to share some routes you want to share the neighbor. Okay, or neighbor means here neighbor routing instances. So and the import policy. If you import route table, all of the route will be shared. If you want to filter, like you share sort of route, after that you can filter some route will be denied or some route will be accepted. So you can maintain through the import policy. Okay. And how we applied RIB in different routing protocols. If you want to take interface routes, we can mention interface routes in RIB group. I will show you in lab. If you want to take route from a different routing protocol, it can be static or it can be dynamic. Okay, so if you want to take some route from dynamic routing protocol, so you have to go those or those dynamic routing protocol and mention or set the RIB. Okay. So this is the basically one example. I show you this example. See here, this is the routing instance, RIB groups. This is the keyword, and RIB groups name is test. And import RIB inet.0, this is the global unicast route table, and the test.inet.0, this is the route custom routing instances. So I want to copy source route table to test.inet.0, test.inet.0, and the global IPv4 unicast or global route that have a WSPF routing protocol. Just go to that routing protocol and match the RIB name and apply your protocol configuration. I- This configuration basically gives you WSPF route will be installed in test.inet.0, which is in inet.0. Just copy inet.0 WSPF route to test.inet.0. Okay, this is the two step basically for import RIP, and for checking just say here route table inet.0 protocol WSPF. This is the protocol WSPF route here that is in inet.0. After configuring RIP, you will get this test.inet.0. This OSPF route copy to test.inet.0. That means custom routing instances. That is the reason. So here inet.0 table share the route to custom routing instances. Name is test.inet.0. So this is basically a route sharing. Okay. So we just go to all that. And this is the router one and this is the router two. Here we already create two routing instances in last classes, and one routing instances we configured OSPF. So if I just show you edit routing instances, instance name is customer A. In customer A routing instances, we have configured virtual router here, connected interface, attach the connected interface, which will be in customer A routing instances, and OSPF for IPv4 and OSPF3 for IPv6. Okay, so check now. This is one routing instances, and another routing instances is routing instances customer B. Routing instances is customer B. So customer B uh, respective interfaces included here, and here is static routing between router 1 and router 2 for IPv4 and for IPv6. Okay. So here is only static route, and their route table is different from customer A routing instances. So check run show route table. Just check one customer A.inet.0. This table have OSPF route. This table have OSPF route. OSPF route is 2.0/24, and another one is 72.1/32. This is the OSPF route. But if you see in see there is no WSPF route here. Any route here? WSPF? No WSPF route here. This is direct, local, static, direct. No WSPF route here. So here 2.0 is WSPF route. See here, 2.0 is here? No. 2.0/24. This route is not in customer B inet.0 route table. Because default routing instances not share the route with other routing instances. This is the reason. So I want to share from one routing instances to another routing instances. Just example, I want to share this OSP route in customer B routing instances. So what will be the configuration? Okay. So first one, edit routing options, set RIB, set RIB groups. You can set custom RIB groups name. I type here my RIB, my RIB group, GRB group, or you can short it my RIB group 1. Next, see three options: export RIB, import policy, and import RIB. So import RIB, then import a import routing table. So I want to copy from customer A route table to customer B route table. So this is my source. This is my source, and I want to copy from source to destination custom B iNet 0. So we define what will be action. Copy the customer A route table to customer B route table. But if I just check customer A route table and B route table, nothing changes here. Check customer B. See here, there is no voice web route here. So need another step. Need another step. So go to edit routing instances. I want to copy from customer A. So edit routing instances, go to customer A routing instances. Here is OSPF, OSPF configuration is here. So let's press set. This OSPF configuration under routing instances. Okay. So need to introduce RIB. Need to introduce RIB. So set protocols. Set protocols OSPF. I'm just checking for IPv4. That's why right here OSPF, and see here the RIB group and mention the RIB group name. We already create the RIB group name is my RIB group 1. So first we create the RIB group and mention what we want and attach or match this RIB group in respective routing instances. In our slide, they want to share inet.0 from inet.0. That means global route table to custom. I show you here one custom route table to another custom route table. Okay, that's why I just go to the custom routing instances and apply the RIB group. Okay, so comment this one and compare the route table custom A. This route table is normal like previous, but if you want to say customer B route table, there is some difference. See here, WSPF route is coming here. Okay. OSPF route is coming here. See, 2.0, 2.024. Yes, 2.024. This is coming here. 72.1/32. Yes, this route is coming here. Okay, understand?
Yes, sir, got it.
Okay, so if you want to filter, all OSPF route is coming. All OSPF route is coming from routing instance A to routing instance B. If you want to filter some route, then you can apply the import policy. You can apply the import policy. Okay. So edit policy action policy statement. Uh, Import policy. So okay, this will be in filter-based forwarding also. So no need. Up to this is okay. Similar example will be filter-based forwarding. Okay. So this is the output, and way, another way you can share route from one routing instance to another routing instances. And this is routing between instances. You can use logical tunnel interface. Logical tunnel interface or physical interface to route between instances. If you want to use this method, RAB grows, there is no need another physical interface or logical interface. But if you if you're not interested to use Arabic groups, then there is alternative solution. You can add physical connection. One physical cable is connect with one port, and another physical cable is connect with another port. So these two port will become used for communication between routing instance 1 and 2. This is the alternative solution. Or if you mm, not use physical connection, you can use logical connection. But logical connection or LT interface, every device have not this feature. Okay, logical tunnel feature. So in that case, if you just wanted to use logical connection or LT, and that will be limitation for some devices. Okay, so in that case, you can use physical connection. So if you use physical connection, that is very simple. Just cable connect and set the point IP address and respective at the respective route. You can use static or dynamic, or you can maintain the filter. Okay. So there is an example of logical tunnel. So I show you here logical tunnel concept. Another example. Okay. So I remove this one. I remove this one, that is edit routing options, delete RIB groups name, my group delete, and another is routing instances, uh, customer A, routing instances, and delete this one, delete protocols OSPF, delete protocols OSPF, and I delete here RIB group, RIB group, RIB group, and yes, RIB group. So there is no error here. Yes, my lab goes to previous the one. Okay. Now I will implement logical tunnel. So first one, run show interface types. This command basically show you interface details. Interface details means interface status, and the protocol status, and IP address configured or not. So see here, any LT interface is here, LT? No, there is no LT interface here. So need to introduce LT interface. Okay. So if you want to introduce LT interface, need to need to check your APC. Run show JNCIS APC pick status. My APC slot is 0 and PIC slot is 0. If you want to see details here, Ranchi Services Server. See here, my card is APC 0, and this card have 1 into 10G, 1 in 10 into 1G port. That means 10 1G port. Okay. And this have one MIC, and including this MIC, PIC is 1. So single PIC have 10 1GB. So I need to introduce, there is only single slot here. So APC 0, PIC 0, and you have to mention logical tunnel bandwidth here. Okay, logical tunnel bandwidth I mentioned here 1G. So after configuring this, you will get one logical interface here. Okay. So LT interface is created. Okay, LT 0 by 0 by first 0 is APC, second 0 is PIC, and last number is automatically generated number. Okay. So if you want to communicate between if just you want to communicate between two routing instances. Okay. So set interface. Interface is this one. This one is your interface. Unit like elephant. Description. This interface will be connect with customer A. Customer A. Okay. And encapsulation is Ethernet. There is multiple encapsulation here, and IP address is family inet address. IP address is example 10108. So next IP I take here 10.1.0.33/30. So show mass LT display set. So this is a LT unit elephant PR unit needs to be configured. See here. So I mentioned here self unit number. If you want to pair with another, I want to pair between routing instance A to B. So my pair unit will be 12. Just example, you can set any number. Okay, commit, check. Yes, my configuration is okay. So just copy this one, copy interface unit 11 to unit 12. Copy done and check the interface 11 and this is the 12. So the description for 12 will for B, customer B, and peer unit will be 11, just vice versa. Okay, and the address will be 33 here, that will be 34. 33, that will be delete this one. So if I see now, just check 11, parent is 12. This interface is for customer A routing instance, and unit 12, parent is 11. This interface is for customer B, and there is the point IP addresses here. If I set commit here, so you can check P2P IP 33 and 34. So first I attach edit routing instances, or you can set here set routing instances. Routing instance is customer A, and interface is lt00.11. Okay, this interface. And set routing instance customer B interface is this LT interface and dot 12. Okay, so you just adding. So if you want to send ICMP run pin, okay, run ping 34 routing instance customer A. Yes, getting. Um, if I want to send ping 33 from customer A routing instances, yes, getting ping. Okay. So if I want to make just like edit routing instances, customer A, if I just include this interface in OSPF, just set protocol OSPF interface, add the interface, this is LT interface, and interface type is P2P. Okay, just enable the OSPF in logical tunnel interface. Okay, from both side, you have to set from both side LT. So now go to routing instances. Routing instances is customer B. Under customer B routing instances, see here, there is no OSPF routing here. So to introduce OSPF routing, set protocols OSPF, set protocols OSPF, area 0, and interface is, interface will be LT customer B, LT dot 12, and interface type is P2P. So see here, your LT interface is added here. LT interface added, and OSPF routing also included here. So comment this one. Run show OSPF neighbor routing ins instance. My instance is customer A. See here, this OSPF now up. So what happened here? Run show route table igniter 0. This table as like before, but I will get change in customer B route table. I will get OSPF route here. Okay, through LT interface, through logical interface. If you want to redistribute direct and static route from routing instance routing instance B to A, that will be possible. Just create the policy and set and apply under OSPF protocols mentioning export policy. So clear, we can
Yes,
do
sir.
this.
Yeah. Sir,
Yeah,
can we create single LT interface or multiple?
yeah, you can use multiple. I use here 2 unit, but there is lots of unit here. Okay, you can use multiple, no issue. Multiple unit. If you want to, mm, if you're asking is this interface unit in single interface, you can use multiple unit. There's one option. Another option is this is a single LT interface. So if you have multiple APC, so you can create multiple LT interface. No
Okay.
issue.
Thank you, sir.
Clear?
Clear.
So this is another option, and other option will be physical, but our lab is basically virtual lab. So there is no possibility to connect one interface just back to connect to single interface, single router. This is not possible in virtually. So in physical scenario, you can check. This is like LT interface. Okay, there's no difference. Okay, so in this option, see here, logical tunnels are not supported all Junos devices. This is the warning basically. So I think RIB is smart. Routing between instances. You can configure its logical tunnel interface is one of the encapsulation type. I use here Ethernet. You can use VLAN interface. Okay, no issue. You can configure IP and IPv6, iOS, MPLS protocol family. You can do in logical interfaces. Okay. The pairing logical interface must belong to the same logical tunnel interface derived from the tunnel services PIC and adaptive services module. Just one thing is, if you mention multiple unit in single physical tunnel interface, that will work. But if you want to mention two unit, but mention two different logical tunnel interface, that will not work. Okay. You can configure only one pair unit for its logical interface. You must configure at least one physical interface statement to enable the logical tunnel interface. At first, if you want to set the logical interface, that will not work. You have to set at least one physical interfaces, or you have to configure minimum one physical interfaces, and logical interface will be activated. Okay. Use physical interfaces to connect and route between routing instances. That is possible. That is basically like logical tunnel interfaces. So that is the end of the section. So just I review this section. This section we introduce routing instances, and here we basically focus the instance type is virtual router. Yeah, virtual router is a completely static concept. You can compare with Cisco VRF. Okay, Cisco VRF Lite. But this is not the dynamic concept. If you just want to virtualize your router, one single physical router to multiple logical router or multiple virtual router, you can deploy this concept. And another option is your RIP groups. And RIP groups will basically help to share route between the routing instances. It can be global to custom routing instance, or it can be custom routing instance to another custom routing instances. So that is the main topics covered in this section. So if you have any query, please ask me. Otherwise, I will stop today.
So is there any limitation of RIV group?
Basically, RIB groups have no limitation, and you can say that in that way, there is import RIB and there is export RIB. So there is a filter option for import RIB, but there is no option for export RIB. Filter option. Okay. But if you consider just all the router you have, you can maintain as per import RIB, that will be okay. No need to export. Maintain the filter in export RIB. But if
Right.
someone say this is the limitation, maybe this is the limitation, but you can do with import RIB, no issue.
No. Thank you.
Okay, so we can close today. So next class, I will discuss load balancing. Okay. This slide basically generated from Juniper Open Learning portal. You will you will take from me, or you can take, or you can self generate from Juniper Learning portal website. Okay. So next class will be load balancing. So thank you very much. Okay.